February 22nd, 1943. The Tunisian desert sun beat down on the captured American tank as Hauptmann Klaus Weber of schwere Panzer-Abteilung 501 watched his reconnaissance troops secure the perimeter around their prize. The M4A1 Sherman, registration USA 3067641, sat motionless on the rocky ground near Sbeitla, its tracks still intact, its engine cold but undamaged. Painted on the front hull, a colourful insignia caught Weber's eye, a mailed fist clutching 3 lightning bolts, the mark of Company G, 3rd Battalion, 1st Armored Regiment. The crew had abandoned it in haste during the chaos of the Battle of Sidi, one of several humiliating defeats that green American troops suffered in their first encounters with German armour. Weber had seen dozens of abandoned American vehicles over the past week, knocked out half-tracks and burned out trucks littering the desert landscape. But this Sherman was different. This one was intact. Operational. The Americans called it War Daddy II. What neither Weber nor his men could have known as they painted German crosses on the hull and prepared to drive their trophy 350 kilometers to the port of Sfax was that this single tank would fundamentally challenge everything German military intelligence believed about American industrial capability. Within days, it would be loaded onto a ship bound for Germany. Within weeks, it would sit in the testing facilities at Kummersdorf, the Wehrmacht's primary weapons proving ground 20 miles south of Berlin. And within months, the conclusions drawn from examining this machine would force German commanders to confront a truth more terrifying than any battlefield defeat. America had built a tank that German industry could not replicate. The German military had entered 1943 with supreme confidence in its armoured superiority. For 3 years, panzer divisions had dominated European battlefields. In Poland, France, the Balkans, and across vast stretches of the Soviet Union, German tanks had crushed opposition with apparent ease. The Panzer III and Panzer IV had proven themselves capable fighting machines. The new Tiger heavy tank, introduced in late 1942, mounted an 88mm gun that could destroy any Allied tank at ranges beyond 2,000 yards. German tank designers had spent the 1930s developing doctrines and technologies that emphasized firepower and armor protection. They had studied the lessons of the First World War, where British and French tanks had terrorized German infantry in the closing months of that conflict. Never again, German planners vowed, would their forces face superior armor without adequate countermeasures. By 1943, they believed they had achieved that goal. The appearance of American tanks in North Africa had initially generated little concern among German commanders. Intelligence reports described the American armour as derivative of outdated British designs, built by a nation with no significant tank-building tradition. The United States Army had entered the war with light tanks barely suitable for reconnaissance. American tank doctrine was unclear, split between infantry support and cavalry exploitation roles. German planners expected American tanks to be crude, hastily produced stopgaps until the Americans could develop proper fighting vehicles. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The first encounters between German and American armour in Tunisia had seemed to confirm these assumptions. At Sidi on February 14th, German forces destroyed or captured dozens of American tanks. At Kasserine Pass 1 week later, inexperienced American units broke and ran when faced with coordinated German attacks. The victories were so complete that some German commanders began to view American armour as negligible, hardly worth serious tactical consideration. But the intelligence officers attached to the Afrika Korps had been paying closer attention. They had noticed something troubling in the wreckage of American vehicles scattered across the battlefield. The tanks themselves, when examined closely, showed sophisticated manufacturing techniques. The armour plates were well formed, properly welded at complex angles. The running gear appeared robust. The radio equipment was far superior to anything the Germans had encountered. Most concerning of all, captured American tankers reported that their units had received their Shermans only months earlier, suggesting production rates that German intelligence found difficult to credit. When the reconnaissance troop from Panzer-Abteilung 501 reported capturing an intact Sherman near Sbeitla, Wehrmacht High Command immediately recognized the intelligence value of such a prize. Standing orders directed that captured enemy equipment in working condition be evacuated to Germany for technical evaluation whenever possible. The Sherman, still bearing its American markings and the nickname War Daddy 2 stenciled on the turret, received priority handling. The journey from the battlefield to the Mediterranean coast required 4 days. German crews had to learn the Sherman's controls on the move, consulting hastily translated fragments of American technical manuals. They discovered, to their surprise, that the tank was remarkably easy to operate. The controls were intuitive, clearly labelled, accessible to the driver without contorting into awkward positions. The visibility from the driver's position far exceeded that of German tanks. The engine started reliably, despite days of sitting abandoned in the desert. At Sfax, longshoremen loaded the Sherman onto a cargo vessel along with other captured equipment bound for evaluation. The ship dodged Allied, air patrols, and submarine threats during its crossing to Italy, then transferred its cargo to a train for the journey north through the Alps to Germany. By mid-March, War Daddy 2 had arrived at Kummersdorf. Kummersdorf had been the centre of German weapons testing since the 1870s, when the Prussian military established an artillery range on the site. By 1943, the facility had expanded into a massive complex of test tracks, firing ranges, workshops, and laboratories. Every significant German weapon system underwent evaluation at Kummersdorf before entering production. Captured enemy equipment received equally thorough examination, providing German intelligence with detailed assessments of Allied capabilities. The arrival of the Sherman generated immediate interest among the engineers and officers assigned to Kummersdorf. Most had seen photographs or read intelligence summaries about American tanks, but none had yet examined one in person. On the morning of May 13, 1943, technicians transferred War Daddy 2 from its railway flat car to the automotive testing section. Over the following days, teams of specialists would methodically disassemble, measure, test, and analyze every component of the American machine. What they discovered would profoundly disturb them. The first assessment focused on basic specifications. The Sherman weighed approximately 33 tons, significantly lighter than the Tiger but comparable to the Panzer IV. Its 5-man crew consisted of commander, gunner, loader, driver, and co-driver/hull gunner, a conventional arrangement. The main armament was a 75mm M3 gun mounted in a fully traversing turret. Secondary armament included a coaxial 30 caliber machine gun, a bow-mounted 30 caliber gun, and a 50 caliber machine gun on the commander's cupola for anti-aircraft defense. None of these specifications alarmed the German evaluators. The 75mm gun was adequate, but not exceptional. The armour, ranging from 12mm minimum to 75mm maximum, offered reasonable protection against most German weapons. The weight and dimensions were unremarkable. On paper, the Sherman appeared to be a competent medium tank, roughly equivalent to the Panzer IV, perhaps slightly inferior to German vehicles in firepower and protection. The revelation came when engineers began examining how the Sherman was built. German tank production in 1943 relied heavily on skilled craftsmen, assembling vehicles using labour-intensive methods. Each tank required hundreds of man-hours to construct. Components were fitted individually, often requiring hand finishing to achieve proper tolerances. Quality control was inconsistent, varying significantly between factories and even between individual vehicles from the same production line. The use of slave labour, while providing bodies for the assembly lines, actually reduced efficiency and introduced sabotage that caused persistent reliability problems. The Sherman, by contrast, showed evidence of mass production techniques that German industry had never successfully implemented for armoured vehicles. Every component exhibited standardization that allowed for interchangeable parts between vehicles. The hull was constructed using large castings and formed plates that minimized the number of welds required. The running gear used rubber block tracks that could be replaced quickly in the field without specialized tools. The engine compartment was designed for rapid removal and installation of the entire power plant, allowing field maintenance crews to swap out engines in hours rather than days. The German engineers documented these findings with a mixture of professional admiration and growing unease. One wrote in his evaluation report, "The preliminary investigation shows that this rolling steel structure is not in itself a bad creation. The Americans have achieved through industrial methods what we have attempted through engineering complexity." The engine compartment particularly impressed the German evaluators. War Daddy 2 was powered by a Continental Er975 radial aircraft engine producing 425 horsepower. The Germans immediately recognized this as a brilliant solution to the problem of wartime production. The United States had enormous capacity to manufacture aircraft engines. By adapting existing radial engines for tank use, American industry could leverage that production capacity without building new specialized facilities. German engineers spent hours examining the engine installation. The entire power plant could be removed as a single unit by disconnecting a limited number of attachment points. All fluid connections used standardized fittings. Filters were easily accessible for maintenance. The cooling system, while somewhat complex, was logically arranged and used proven. Automotive components. Every aspect of the design prioritized maintainability under field conditions. One senior engineer noted in his report, "A German tank mechanic would find this engine compartment a revelation. The ease of troubleshooting and maintenance far exceeds our own vehicles. Component access does not require specialized training or tools. This suggests an industrial philosophy fundamentally different from our own approach." The transmission and final drive assemblies revealed similar attention to reliability and maintainability. The Sherman used a 5-speed transmission with synchromesh on the upper gears, allowing smooth shifting even by inexperienced drivers. The final drives employed herringbone-cut gears that distributed stress across multiple gear teeth, dramatically extending service life compared to the straight-cut gears used in German tanks. This detail became significant when German engineers compared the Sherman's final drive design to their own vehicles. The Panther tank, Germany's newest and most sophisticated medium tank, suffered chronic final drive failures. The straight-cut gears in the Panther's final drives typically lasted only 150 kilometers before requiring replacement. Combat units reported that final drive breakdowns were the single most common cause of Panther immobilization, often leaving tanks stranded in exposed positions where they could be destroyed by enemy fire or captured. The Sherman's herringbone gears, tested under controlled conditions at Kummersdorf, showed minimal wear after 500 kilometers of operation. Extrapolating from these results, German engineers estimated the Sherman's final drives might last 1,500 to 2,000 kilometers under normal conditions, perhaps 10 times the lifespan of Panther components. One engineer wrote bitterly, "The Americans have solved with intelligent design what we cannot overcome despite superior metallurgy. This is a troubling indicator of their present industrial capability." The electrical system revealed another area where American design philosophy diverged dramatically from German practice. The Sherman employed dual generators, including an auxiliary unit with its own independent motor. This allowed the tank's electrical systems and turret traverse to operate without running the main engine, conserving fuel and reducing the risk of detection. The batteries could be charged while the tank sat in a defensive position, maintaining readiness without the constant engine operation that German tanks required. All radios in the Sherman were FM frequency modulation sets, representing cutting-edge communications technology for 1943. German tanks still relied primarily on AM amplitude modulation radios, which were more susceptible to interference and had shorter effective range. The American radios included crystal-controlled frequency selection, eliminating the time-consuming tuning procedures that German radio operators endured. Communication equipment particularly impressed the German signals officers who examined War Daddy 2. The quality of the radio components, the clarity of reception, the reliability of transmission, all exceeded German equipment. More concerning was the obvious conclusion. If the Americans could equip their tanks with such sophisticated communications gear, It suggested broader industrial capabilities that German intelligence had significantly underestimated. But perhaps the most disturbing discoveries came not from individual components, but from the overall design philosophy evident in every aspect of the Sherman's construction. The tank had been engineered from the beginning for mass production, for operation by minimally trained crews, for maintenance under primitive field conditions. Every design decision prioritized reliability over performance, standardization over optimization, ease of production over theoretical superiority. German tank design followed the opposite philosophy. Engineers pursued maximum performance, accepting complexity as the price of superiority. The Panther packed a powerful 75mm high-velocity gun, thick sloped armor, and sophisticated suspension into a vehicle that required extensive crew training and constant maintenance. The Tiger mounted an 88mm gun that could destroy any Allied tank at extreme range, housed in armor up to 100mm thick. Both vehicles represented engineering triumphs, technological showcases that demonstrated German technical prowess. But both vehicles were also mechanical nightmares that broke down with alarming frequency, required extensive maintenance, consumed fuel at rates that strained logistics, and could be produced only in limited numbers, using scarce resources and skilled labor. The Sherman represented a fundamentally different approach. It was good enough, not optimal, not superior in any single category, but adequate across all requirements, while being simple enough to build by the tens of thousands, reliable enough to operate with minimal maintenance, straightforward enough that 18-year-old draftees could be trained to use it effectively in months rather than years. This realization troubled the German evaluators more than any specific technical inferiority. If the Americans could build tanks with this level of quality while still achieving mass production, what did that imply about American industrial capacity? The captured Sherman had been built at the Lima Locomotive Works in July 1942, one of several factories producing the tank. Intelligence suggested that the Americans were manufacturing Shermans at a rate of over 2,000 per month. German tank production in early 1943 ran at roughly 250 vehicles monthly across all types. The mathematics were stark and undeniable. Even if German tanks were individually superior, which many German officers still insisted they were, could quality overcome a 10-to-1 numerical disadvantage? Could superior training and tactics compensate for being outnumbered by such margins? Could Germany sustain a war of attrition against an enemy with such overwhelming production advantages? These questions would be central to the armaments conference scheduled for early June at the Hillersleben artillery range, where captured Allied equipment would be demonstrated for senior Nazi officials and military commanders. War Daddy 2 would play a starring role in those demonstrations, its capabilities showcased alongside Germany's newest weapons. But the real message of those demonstrations would be far more troubling than any simple technical comparison. The Sherman tests at Kummersdorf continued through late May. Engineers measured every aspect of the tank's performance. They drove it over rough terrain to assess suspension characteristics. They fired the main gun repeatedly to evaluate accuracy and rate of fire. They timed how quickly crews could perform maintenance tasks. They measured fuel consumption under various operating conditions. They even conducted penetration tests, firing captured American ammunition at armored targets to determine the 75mm gun's capabilities. Every test generated data that would be compiled into comprehensive reports. But beyond the numbers and specifications, beyond the measured performance metrics, the engineers at Kummersdorf reached an intuitive understanding that transcended formal analysis. The Sherman was not a better tank than the Panther or Tiger by conventional measures. It was a more important tank. It represented an industrial system capable of producing sophisticated war machines in quantities that German industry, despite years of militarization and total war mobilization, could not match. One engineer summarized this conclusion in his report with unusual candor. "We have examined the American tank exhaustively. We find it to be competently designed, solidly built, and remarkably reliable. It is not in all respects superior to our vehicles, but that is not the relevant question. The relevant question is whether we can destroy American tanks faster than American factories can build them. Based on what we observe in this single vehicle's construction quality, we must conclude that we cannot. This was the truth that German intelligence had been reluctant to face, the reality that political leadership refused to acknowledge. America possessed industrial capabilities that dwarfed anything Germany could mobilize. The Sherman, with its elegant simplicity and manufacturing efficiency, was merely one visible manifestation of those capabilities. If the Americans could build tanks like this while simultaneously producing aircraft by the tens of thousands, warships by the hundreds, artillery pieces beyond counting, what hope did Germany have in a prolonged conflict? The question would become even more pressing as German forces in Tunisia collapsed. By May 13th, the same day War Daddy II arrived at Kummersdorf for testing, German resistance in North Africa had effectively ended. Over 250,000 Axis troops surrendered to Allied forces, the largest capitulation of German soldiers since Stalingrad 4 months earlier. Among the captured equipment were numerous German tanks, some abandoned due to mechanical failures, others knocked out by increasingly confident Allied forces, including American tank units equipped with Shermans. The propaganda magazine Die Wehrmacht would publish an article about War Daddy II in late June, presenting the captured Sherman as evidence of German technical superiority. The article praised German soldiers for capturing the enemy tank while emphasizing that German armor remained the finest in the world. Photographs showed German personnel examining the Sherman, pointing to various features, demonstrating Germany's thorough understanding of enemy capabilities. But privately, senior officers who attended briefings on the Kummersdorf test results came away with very different impressions. The Sherman might not be invincible, but it was inexorable. German tanks might win individual engagements, but they could not stop the tide of American production. Quality alone could not overcome quantity when the quality gap was small and the quantity gap was vast. These concerns would be on display at Hillersleben in early June, when Reichsminister Albert Speer, Hitler's Minister of Armaments and War Production, would personally inspect War Daddy II and other captured Allied equipment. Speer had been pushing for increased tank production, for simplification of German designs, for rationalization of the armaments industry to achieve efficiencies comparable to Allied production. The captured Sherman would become a physical argument for his position. On June 6th and 7th, 1943, senior Nazi officials, military commanders, and industrial leaders gathered at Hillersleben for an armaments conference that Hitler himself chose not to attend. The program included demonstrations of Germany's latest weapons alongside captured Allied equipment. War Daddy II was positioned prominently among the vehicles on display. Speer arrived at the demonstration grounds on the morning of June 6th. A tall man with an architect's attention to detail, he had transformed German armaments production since taking over the ministry in February 1942. Under his leadership, production had increased dramatically despite Allied bombing and the military disasters on the Eastern Front. But Speer understood that increased production meant nothing if Germany's enemies were increasing their production even faster. He climbed into War Daddy II for the first time that morning, settling into the commander's position. Photographs captured the moment. Germany's most powerful civilian administrator sitting in an American tank, his expression thoughtful as he examined the interior. The tank was more spacious than German vehicles he had toured. The controls were clearly marked in English, their purpose obvious, even without translation. The commander's position offered excellent visibility through the cupola. Everything about the interior suggested that American designers had prioritized crew comfort and efficiency. Speer spent nearly 20 minutes in the Sherman, asking questions of the German engineers who had conducted the Kummersdorf tests. How long did the engine run between major overhauls? What was the expected service life of the transmission? How quickly could field maintenance crews replace damaged components? The engineers provided detailed answers, citing test data and projections. Every answer reinforced the same conclusion. American industry had achieved something remarkable. Later that morning, demonstration crews drove the Sherman up a steep slope that had been prepared as a testing ground. The tank struggled on the incline, its tracks losing traction on loose soil. Eventually, it stalled partway up the slope, unable to complete the climb. German observers nodded approvingly. The Sherman had failed a test that German tanks could complete. But was this a meaningful demonstration of superiority, or merely propaganda for domestic consumption? The Sherman had not been designed for extreme mountain terrain. It had been designed for reliable performance across the widest possible range of conditions, for rapid production in the largest possible quantities, for operation by crews with minimal training. Judged by those criteria, the hill-climbing failure was irrelevant. A Panther tank followed the Sherman up the slope. The Panther, Germany's newest medium tank, successfully climbed the incline that had defeated the American vehicle. Observers applauded. Here was proof that German engineering remained superior, but several officers in the audience who had served on the Eastern Front exchanged knowing glances. They had seen plenty of Panthers fail to climb slopes in combat. They had seen Panthers break down on level roads, their final drives disintegrating after minimal use. They had seen Panthers burn their engines on long marches, their cooling systems unable to handle sustained operation. The successful demonstration proved that the Panther could climb one particular slope on one particular day. It did not prove that the Panther was a better tank for the kind of war Germany was actually fighting. Speer understood this distinction. After watching the demonstrations, he met privately with senior armaments, officials, and military commanders. The discussions focused on production capacity, resource allocation, and Germany's strategic situation. Speer argued that Germany needed to simplify tank designs, to focus on vehicles that could be produced in larger numbers, to prioritize reliability over maximum performance. The Sherman, he suggested, offered lessons that German industry should heed. The proposal met resistance from military officers, who insisted that German technological superiority must be maintained at all costs. Tank production should emphasize quality over quantity, they argued. One Tiger was worth 5 Shermans, one Panther worth 3. Therefore, Germany should build the best tanks possible, accepting lower production numbers as the price of superiority. Speer countered with mathematics. If one Tiger was worth 5 Shermans, but the Americans could build 50 Shermans for every Tiger Germany produced, how did that ratio favor Germany? If the Panther was superior to the Sherman but broke down every 150 kilometers, while the Sherman ran for 1,500 kilometers, which tank would actually be present on the battlefield when combat occurred? These arguments would continue throughout the war. Germany would continue to pursue increasingly complex, increasingly capable, increasingly unreliable tank designs. The Panther would be produced in larger numbers than the Tiger, roughly 6,000 vehicles compared to fewer than 2,000 Tigers. But compared to American production of nearly 50,000 Shermans, German numbers remained trivial. The strategic implications extended beyond simple production comparisons. Every Tiger or Panther that broke down due to mechanical failure represented not just a lost vehicle, but lost combat potential. Tanks sitting in repair depots could not defend against enemy attacks. Tanks awaiting replacement parts could not exploit tactical opportunities. Tanks that required specialized mechanics and extensive training could not be fielded quickly to replace losses. The Sherman's reliability meant that American armored divisions could maintain higher operational readiness rates. Units equipped with Shermans could conduct sustained operations without the constant mechanical attrition that plagued German armored formations. When Shermans did break down, standardization of parts and the simplicity of repairs meant that field maintenance crews could return them to service quickly. German maintenance capabilities, by contrast, struggled to support the increasingly complex vehicles being fielded. The Panther required specialized tools for many repairs. Replacement parts were not always interchangeable between vehicles produced at different factories. The sophisticated final drives needed skilled mechanics and often had to be sent to rear area workshops for rebuilding. Tank units spent enormous amounts of time and resources simply keeping their vehicles operational. These maintenance burdens became especially acute on the Eastern Front, where vast distances, primitive infrastructure, and extreme weather conditions exacerbated every mechanical problem. German tank units routinely lost more vehicles to breakdowns than to enemy action. Recovery vehicles struggled to tow the heavy German tanks across muddy terrain. Repair facilities could not keep pace with the constant stream of broken equipment requiring attention. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Soviet forces, meanwhile, received thousands of American Shermans through Lend-Lease shipments. Soviet tanker Dmitry Loza, who commanded Sherman-equipped units, later wrote extensively about the American tank's strengths and weaknesses. Loza praised the Sherman's reliability, its excellent radio equipment, its auxiliary power unit that kept batteries charged without running the main engine. He noted that Soviet mechanics appreciated the straightforward maintenance requirements compared to Soviet-built tanks. Loza also acknowledged the Sherman's vulnerabilities. The high profile made it easier for German gunners to hit. The narrow tracks struggled in mud and snow compared to the wider tracks of Soviet tanks. The gasoline engine was more prone to fire than diesel power plants. But Loza emphasized that these disadvantages were accepted because the tank's overall reliability and ease of use made it an effective combat vehicle. German forces also used captured Shermans whenever possible, often converting them into armored recovery vehicles. Tiger and Panther units particularly valued captured Shermans for recovery operations. The reliable engine and robust drivetrain made the Sherman ideal for towing broken-down German tanks. Some units removed the Sherman's turret to create improvised recovery vehicles, a bitterly ironic application of American engineering. The fact that German tank crews preferred captured Shermans for recovery work spoke volumes about relative reliability. A Panther could theoretically tow another Panther, but so often the recovery vehicle itself would break down during the operation, leaving two disabled tanks instead of one. Tiger units faced similar problems with their purpose-built recovery vehicles, which shared the Tiger's mechanical fragility. The Sherman, designed for reliability above all else, could perform recovery operations consistently without adding to the maintenance burden. German soldiers who operated captured Shermans reported positive experiences with the tank's handling characteristics. The transmission shifted smoothly even under load. The engine started reliably in all weather conditions. The visibility from the driver's position far exceeded German vehicles. The crew compartment was spacious enough for men to operate efficiently even during extended periods in the vehicle. One German tank commander wrote in his diary, "The American tank is comfortable. This is not a word I would use to describe our Panther. The Americans have built a tank for humans to fight in. We have built a tank for heroes to die in." This assessment, while harsh, reflected the reality that German tank design prioritized combat performance over crew survivability and comfort. The Panther's interior was cramped, hot, and prone to filling with carbon monoxide when the ventilation system could not keep pace with engine exhaust. The Tiger was somewhat better, but still far less habitable than the Sherman. German crews endured conditions that would have been considered unacceptable by American standards. The ergonomic differences were not mere luxuries. Crew fatigue affected combat performance. Tired, uncomfortable crews made mistakes, reacted more slowly, suffered degraded situational awareness. The Sherman's superior crew accommodations translated into better combat effectiveness over extended periods. An American tank crew that had spent 12 hours in their vehicle could still fight effectively. A German crew in a Panther after 12 hours was exhausted, irritable, and less capable. These human factors rarely appeared in technical evaluations or performance specifications, but they mattered enormously in actual combat. Tank warfare involved long periods of waiting and movement, punctuated by brief moments of intense action. The Sherman's design recognized this reality and optimized for sustained operations. German tanks optimized for maximum performance in ideal conditions, accepting that actual operations would fall short of that ideal. The captured Sherman also revealed American approaches to manufacturing that went far beyond simple mass production. The quality of welds, the precision of machining, the consistency of component fabrication, All indicated sophisticated quality control throughout the production process. German intelligence had assumed that American mass production meant crude, hastily built vehicles. War Daddy 2 demonstrated that mass production could coexist with high quality when properly organized. American factories employed assembly line techniques pioneered in the automotive industry, adapted for tank production. Workers specialized in specific tasks, building expertise through repetition. Components were manufactured to precise tolerances that allowed interchangeable installation. Subassemblies were tested before final installation. Every vehicle rolled off the production line meeting the same specifications, a consistency that German production never achieved. This manufacturing excellence reflected broader differences in industrial organization. American factories operated with motivated workers earning good wages under relatively safe conditions. German factories increasingly relied on slave labor, poorly fed prisoners forced to work excessive hours under brutal overseers. Slaves had no incentive to produce quality work, and every incentive to sabotage when possible. Cigarette filters jammed into oil passages, weakened welds in critical components, deliberately misaligned parts that would fail under stress. These acts of resistance undermined German production in ways that were difficult to detect and impossible to eliminate. The implications were profound. Not only could America produce more tanks, American tanks were more reliable because they were built by willing workers who took pride in their craftsmanship. German tanks were less reliable, partly because they were built by slaves who hoped the vehicles would fail. In the contest between democracy and tyranny, even manufacturing quality became a weapon. German leadership largely refused to acknowledge these realities. Hitler insisted that German weapons were superior, that quality would triumph over quantity, that Germanic technical genius would overcome any material disadvantage. Many senior officers shared this conviction, dismissing concerns about American production capabilities as defeatist thinking. The propaganda apparatus continued to emphasize German victories and minimized setbacks, creating an alternate reality where the war was going well. But the men who had examined War Daddy 2 at Kummersdorf knew better. They had seen the evidence of American capability, had measured it, had tested it, had understood its implications. Their reports documented these findings in meticulous detail. Some officers read those reports and grasped the strategic hopelessness of Germany's situation. Others read the same reports and found reasons to dismiss the conclusions, to believe that German superiority would somehow prevail despite the mathematics of industrial production. This cognitive dissonance pervaded German military thinking throughout the war. Officers could simultaneously acknowledge that American production vastly exceeded German capacity while believing that German forces would ultimately win. The Sherman was inferior to the Panther, therefore German tanks were superior, therefore Germany would triumph. The logic was comforting but fundamentally flawed. Superiority meant nothing if you were outnumbered 10-1, outproduced 20-1, outsupplied 50-1. The Battle of Normandy in summer 1944 would demonstrate these principles with brutal clarity. In Normandy were equipped with Panthers, Tigers, and other sophisticated vehicles. Allied forces, predominantly American and British, employed Shermans in overwhelming numbers. German tanks won many individual engagements, knocking out multiple Shermans for each German loss. But the Shermans kept coming, in numbers that German forces could not match, supported by artillery that German units could not counter, backed by logistics that German supply lines could not rival. By the time the Normandy campaign concluded, German armoured forces in the West had been effectively destroyed, not because German tanks were inferior, but because there were not enough of them, and those that existed could not be sustained in combat. Shermans lost in battle were replaced within days. Panthers lost in battle might not be replaced for weeks or months, if at all. Sherman crews who lost their tank received a new vehicle and returned to combat. Panther crews who lost their tank might find themselves fighting as infantry because no replacement vehicle was available. This was the war of attrition that Germany could not win, the conflict where American industrial might ground down German military power through sheer overwhelming force. The Sherman was both symbol and instrument of that victory, the tank that was good enough multiplied by numbers that were more than enough. The story of War Daddy 2 did not end at Hillersleben. After serving as a demonstration vehicle, the Sherman was eventually assigned to Tank Company Kummersdorf, a composite unit formed in late 1944 from various vehicles at the testing facility. This unit included 2 captured Shermans, several German tanks, and miscellaneous other equipment. It saw combat in the final desperate weeks of the war, fighting Soviet forces advancing on Berlin. By that point, the questions raised by the examination of War Daddy 2 in early 1943 had been answered decisively. American industrial capability had indeed proven decisive. German technological advantages had indeed been insufficient. The war that German leadership insisted could be won through superior will and better weapons had been lost through inadequate production and broken logistics. The engineers who had examined War Daddy 2 at Kummersdorf in spring 1943 had warned of these outcomes. Their reports had documented American capabilities with precision. They had identified the fundamental mismatch between German and American industrial capacity. They had explained why quality alone could not overcome quantity when the quality gap was small and the quantity gap was enormous. Their warnings had been noted, filed, and largely ignored by leadership that preferred comfortable illusions to uncomfortable truths. One senior engineer's report from May 1943 proved eerily prescient. After weeks of testing and analysis, he concluded, "We have examined the American Sherman tank exhaustively and reached several conclusions. First, it is a competent design that effectively balances firepower, protection, and mobility for its intended role. Second, it demonstrates manufacturing sophistication that allows mass production without compromising quality. Third, it reflects an industrial philosophy that prioritizes reliability and maintainability over maximum performance. Fourth, and most significantly, if this tank represents the baseline for American armored vehicle production, then we face an adversary whose industrial capabilities dwarf our own. We can build superior individual tanks, but we cannot build enough tanks to match their production. We can achieve better performance, but we cannot sustain that performance in the field. We can win battles, but we cannot win the war of industrial attrition that this conflict has become. The Sherman is not a super weapon. It is something more dangerous, an adequate weapon produced in overwhelming quantity. This assessment captured the essential truth that German leadership refused to face. The Sherman was not the best tank of World War II by most technical measures. The Panther had better armor, better armament, better tactical mobility in many conditions. The Soviet 34 had excellent protection and good firepower for its weight class. The German Tiger mounted a devastating gun in a nearly impenetrable hull. But the Sherman was the most important tank of the war, the vehicle that exemplified the industrial might that decided the conflict's outcome. The Sherman's true significance lay not in its specifications, but in what those specifications represented. An industrial system capable of producing sophisticated war machines in quantities that changed the calculus of warfare. Before mass production of complex weapons like the Sherman, wars were won through superior skill, better tactics, more motivated soldiers. The Industrial Revolution had been changing this equation for decades, but World War II marked the point where industrial capacity became the decisive factor overshadowing all others. Germany entered the war with excellent soldiers, effective tactics, and sophisticated weapons. Germany lost the war because it could not match the industrial output of its enemies. The Soviet Union absorbed catastrophic losses in 1941 and 1942, then rebuilt its forces with production that German intelligence found difficult to credit. Britain, despite being bombed relentlessly and fighting across multiple continents, maintained industrial production that sustained its military efforts. The United States, protected by oceans from direct attack, built the largest military-industrial complex in human history. The examination of War Daddy 2 at Kummersdorf provided German analysts with a window into American capabilities. That window revealed a vista that should have been terrifying. Factories producing thousands of tanks monthly, shipyards, launching ships faster than U-boats could sink them, aircraft plants delivering bombers by the hundreds. The Sherman was merely one product of this industrial juggernaut, a visible manifestation of capabilities that extended across every category of military hardware. Some German officers understood what they were seeing and recognized the implications. General Heinz Guderian, Inspector General of the Panzerwaffe, opposed continued production of heavy tanks like the Tiger and wanted resources directed to simpler vehicles that could be built in larger numbers. His arguments were technical, tactical, and strategic. Technically, the big cats were over-engineered and unreliable. Tactically, they lacked the mobility to exploit breakthroughs. Strategically, they consumed resources that could produce multiple lighter tanks. Guderian's perspective aligned with the lessons evident in the Sherman's design. Build adequate tanks in large numbers rather than superior tanks in small numbers. Prioritize reliability over maximum performance. Design for mass production and field maintenance. Accept good enough as a legitimate engineering goal. These principles ran counter to German military culture, which valued technical excellence and disdained compromise. But these principles won the war. Albert Speer, after inspecting War Daddy II at Hillersleben, pushed for rationalization of German tank production along similar lines. He wanted standardized components across vehicle types, simplified designs that used fewer resources, production methods that could achieve higher output. He secured some improvements, increasing tank production significantly during 1943 and 1944, despite Allied bombing and resource shortages. But he could never overcome the fundamental constraints. Germany lacked the raw materials, the industrial infrastructure, the skilled workforce, and the strategic position to compete with Allied production. The final irony was that Germany's pursuit of superior tanks actually hastened its defeat. Resources devoted to developing and producing Panthers and Tigers could have built larger numbers of improved Panzer IVs, which were adequate for most combat situations and far more reliable. The Panzer IV remained in production throughout the war precisely because it was the most practical German tank, a tacit admission that simpler was better. But Germany also continued to pour resources into over-engineered monsters that broke down constantly and could not be produced in meaningful numbers. This pattern reflected broader problems in Nazi Germany's approach to industrial warfare. The regime valued symbols of technological prowess over practical effectiveness. Hitler personally involved himself in weapons design, insisting on features that complicated production and reduced reliability. The command economy, despite total control over resources, proved less efficient than market-based Allied economies at organizing production. Propaganda requirements often trumped military necessity, with weapons designed more for psychological impact than tactical effectiveness. The Sherman, freed from these pathologies, embodied a ruthlessly pragmatic approach. Every design decision served a purpose: reliability, maintainability, producibility, or crew effectiveness. Nothing was included merely for prestige. Nothing was over-engineered to achieve marginal performance gains. The goal was to build a tank that could be produced by the tens of thousands, operated by minimally trained crews, and maintained under field conditions. By those criteria, the Sherman succeeded brilliantly. Modern analysts sometimes criticize the Sherman for not being upgunned sooner to match German tanks. This criticism misunderstands American tank doctrine and production realities. The 76mm gun was available and in production by mid-1944, but frontline units initially refused it because the high-velocity weapon produced excessive muzzle blast that obscured the gunner's vision. When combat experience in Normandy demonstrated the need for better anti-tank capability, 76mm Shermans were rushed forward and quickly proved their worth. More fundamentally, the Sherman was never intended to primarily fight other tanks. American doctrine called for tank destroyers, specialized anti-tank vehicles, to engage enemy armor while tanks exploited breakthroughs and supported infantry. This division of labor made sense given American industrial capabilities, which could produce both tanks and tank destroyers in abundance. When circumstances forced Shermans into tank versus tank combat, they often prevailed through superior tactics, better crew training, and overwhelming numbers. The tank duel between Sherman and Panther has captured popular imagination, feeding narratives about German technical superiority. Reality was more complex. In direct combat between equally skilled crews in equal numbers, the Panther held advantages in firepower and frontal armor. But such encounters were rare. More typically, multiple Shermans engaged a single Panther from multiple angles, negating its armor advantage. Or American artillery destroyed Panthers before they could engage. Or Panthers broke down before reaching combat. Or airstrikes eliminated Panthers while they were being transported to the front. Statistics from Northwest Europe between D-Day and war's end tell the story. American armored forces lost approximately 1.9 Shermans for every Panther they destroyed. This exchange ratio was acceptable given that American production delivered new Shermans constantly, while German Panther production could not replace losses. Moreover, many Sherman losses were to anti-tank guns, mines, and other causes rather than Panther fire. The Panther's theoretical superiority over the Sherman mattered far less than the fact that Shermans were present in overwhelming numbers while Panthers were increasingly scarce. The crews of War Daddy II, who had abandoned their tank near Sbeitla in February 1943, never knew that their vehicle would end up in Germany, examined by enemy engineers, demonstrated before Nazi leadership, and eventually destroyed fighting Soviet forces in the defense of Berlin. They likely never knew that their tank serial number and unit markings would be photographed, documented, and preserved in German archives. They certainly could not have imagined that their Sherman would become a symbol of American industrial power, an artifact whose examination forced German analysts to confront uncomfortable truths about the war they were losing. The story of War Daddy II encapsulates the broader narrative of American involvement in World War II. Early defeats and humiliations in Tunisia gave way to growing competence as American forces gained experience. The industrial might that had seemed peripheral to the conflict in 1941 became the decisive factor by 1943. Weapons that appeared adequate rather than superior proved more than sufficient when produced in overwhelming quantity. An approach to warfare that emphasized logistics, production, and systematic application of resources overcame tactical brilliance and technical sophistication. For Germany, the examination of War Daddy II should have been a wake-up call, a clear signal that the strategic situation was hopeless. American industrial capabilities made German defeat inevitable, unless Germany could somehow force a negotiated settlement before American production reached its full potential. By mid-1943, when German engineers completed their analysis of the captured Sherman, that window had closed. American and British forces had driven Axis forces from North Africa, invaded Sicily, and were preparing to attack the Italian mainland. Soviet forces had turned the tide on the Eastern Front and were beginning a long advance toward Berlin. The strategic situation would only deteriorate further as American production continued to expand. Yet Germany fought on for 2 more years, sacrificing millions more lives in a war that could not be won. The engineers who examined War Daddy II and understood its implications had no power to change German strategy. Their technical reports documented reality, but reality was unwelcome in a regime built on ideology and propaganda. The truth about American industrial superiority was available to anyone willing to see it, evident in every Sherman that rolled off American production lines. But truth is powerless when leadership refuses to acknowledge it. The legacy of the Sherman extends beyond its role in World War II. The principles embodied in its design, reliability over maximum performance, maintainability over complexity, quantity alongside quality, these became foundational to American military procurement in the post-war era. The M48, M60, and Monet Abrams main battle tanks all reflected lessons learned from the Sherman experience. American industry's ability to produce sophisticated weapons in large quantities remained a decisive advantage through the Cold War and into the 21st century. For tank enthusiasts and military historians, the Sherman remains endlessly fascinating precisely because it defies simple categorization. It was not the best tank of World War II, but it was perhaps the most important. It won not through superior specifications, but through superior strategy. Be good enough, be reliable enough, and be present in overwhelming numbers. This is a less romantic narrative than tales of lone tigers destroying entire tank companies, but it is a more accurate reflection of how industrial wars are actually won. The specific fate of War Daddy II after serving in Tank Company Kummersdorf remains uncertain. The unit was destroyed in fighting south of Berlin in April 1945. Some vehicles may have been captured by Soviet forces, others destroyed in combat, still others abandoned as fuel ran out and ammunition was exhausted. The Soviets photographed captured American equipment at Kummersdorf after the war, and one Sherman appears in those photographs, though whether it was War Daddy II specifically cannot be confirmed from the images. What remains certain is that the tank's brief time under German control provided invaluable intelligence about American capabilities. The reports generated from examining War Daddy II accurately predicted the outcome of the war. German quality could not overcome Allied quantity. German technical sophistication could not compensate for inadequate production. German tactical excellence could not overcome strategic industrial inferiority. These predictions proved accurate in every particular. The Sherman tank was not a superweapon. It did not single-handedly win World War II. It was not invincible on the battlefield. But it was exactly what the United States needed: a reliable, maintainable, producible combat vehicle that could be built in the quantities necessary to equip Allied forces worldwide. In that role, it succeeded completely, becoming the backbone of American and Allied armored forces from North Africa through the final push into Germany. The German engineers who examined War Daddy II in spring 1943 saw beyond the specifications and performance metrics to understand what the Sherman represented: a nation with industrial capacity beyond anything Germany could match, mobilized for war and determined to win through overwhelming material superiority. Their analysis was technically precise and strategically prescient. The warnings they issued went unheeded by leadership, unwilling to face uncomfortable realities. And so Germany fought on toward inevitable defeat, its armies ground down by the same industrial might that had produced the Sherman tank. In the end, the examination of one captured American tank revealed the outcome of the entire war. Not because the Sherman was a wonder weapon, but because it embodied industrial capabilities that made Allied victory inevitable. The real question raised by examining War Daddy II was not whether the Sherman was a good tank. It was whether Germany could survive a war against an industrial power that could produce good enough tanks by the tens of thousands, while simultaneously building the largest air force, the most powerful navy, and the most comprehensive logistics system in military history. The engineers at Kummersdorf knew the answer to that question in May 1943. German leadership refused to accept that answer until May 1945, when Soviet flags flew over the ruins of Berlin and the Third Reich lay in ashes. The 2-year gap between recognition and acceptance cost millions of lives and accomplished nothing except prolonging Germany's agony. That tragedy was written in the specifications of a single American tank, examined by German engineers who understood what they were seeing but could not change the course of a war already lost. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.